Hi, welcome to what will be a few lectures about Newton's laws of motion. This is chapter 4 of Giancoli, 7th edition, actually also 5th edition, for AP Physics 1 at West High School. So my aim in this lecture is to discuss force, Newton's first, second, and third law of motion, mass, and mass versus weight versus normal force. We'll look at solving problems with Newton's laws using free body diagrams, and we'll look at problems involving friction and inclined planes. So simply put, a force is a push or a pull. Anytime something is touching another object and pushing or pulling on it, we will expect a force to be exerted. An object at rest requires a force to cause it to move, and a moving object needs a force to change its velocity. This is a hint at Newton's first and second laws. The magnitude of a force can be measured using a spring scale. We will deal with contact forces for the most part, so objects touching each other will exert forces on each other. We will also consider some field forces, but the field forces we consider will be limited to the pull of gravity, gravitational force, and electrostatic force later in the year. Newton's first law of motion states that every object continues in its state of rest or of uniform velocity in a straight line. That's a little redundant, but uniform motion in a straight line, as long as no net force acts on it. And the key here is no net force, not no force, but no net force. The sort of colloquial version of this is that things keep doing what they're already doing unless a net force is exerted on them. The law of inertia refers to the inertia of an object that's measured as its mass, and mass is a measurement of the amount of matter in an object. Inertial reference frames are frames of reference in which Newton's first law is valid, and inertial reference frames exclude rotating and or accelerating reference frames. Rotation is a form of acceleration, so that's also redundant, but Newton's laws only hold when the frame of reference is not accelerating. Mass is a measure of inertia of an object. Mass is a measurement of the amount of matter in an object, and in the SI system of units, mass is measured in kilograms. Mass and weight are not the same thing, although they are on Earth directly proportional to each other, so we often use them interchangeably. Weight is the force of gravity exerted on an object by some other object with mass, and gravitational pull is dependent on the other object that's exerting that force. So your weight on Earth may be 600 newtons, but if you go to the moon, where the gravitational pull is less than the pull on Earth, it's about a sixth less, you will weigh about a sixth as much as you weigh on Earth. Your mass won't change. Mass, the amount of matter contained in you, depends on you. So you have to change your body to change your mass, but you can change your weight by moving somewhere else in the universe.